Hello everyone, welcome to this video. In this video, we are going to take a look at one of the most interesting problems from IRODOV's general physics, and this problem will include applications of Newton's laws of motion and definite integration, and in addition to that, there will be differential equations. So if you're not aware of these topics, I will explain them from scratch and will try to be as detailed as possible. And I'm going to provide a generalization of this problem, which appeared in 140th problem, I think, in IRODOV, which I posted like 4 years back on my blog. I'm also going to provide a link in the description to that. So let's jump right in and see what the question is. So as you can see, we have this figure, and this is Irodov problem 140. And it says that we have a block of mass m where it is located right here. So this is the block of mass m. And we also have a block of b called mass m. Now this block A is first of all attached to a thread from the point P, which is on this frictionless surface, also attached to a spring from the point O. And again, it is also attached through a pulley, which is inextensible. And this is here, which is connected to the block B. Now, the problem here says that this thread right here is burned. And once it starts burning, this block will start to move towards the right. Once it starts burning, the block will move towards the right, and it will, at some point, it is going to cross this edge. We need to find out what is the velocity of this block when it crosses this edge, or when it basically is about to fall off the edge. And I think it was given that k is equals to 5 mg by L, where L is the length of the string and m is the mass of the block. For block A and block B, they are the same mass, and we have this. So k is basically the spring constant of the spring. Now, let's say this is ceiling, from where the point O is there, and from where the spring is basically hanging, right? This is the spring, let's say. And when the block moves some distance, the spring becomes this. It becomes a bit extended, right? So the block initially was here, and now the block is here. Okay. This is the block of mass m, and let's call this the block A. So it has traveled a distance like this. Okay. We need to understand what happens to this block. First of all, let this angle be theta. When this angle is theta and this length is basically L, this here, according to trigonometry, should become L into sec theta. You can simply take cosine of theta. It will give you L upon this length. So this length would be L into sec theta. Okay. What is this length? So the extended length, let's call it L prime, is equal to L sec theta. And in that case, the extension of the string x is basically L prime minus L, which is L sec theta minus L, or in other words, L whole into sec theta minus 1. Okay. Okay. So let's draw a clearer diagram and understand what else is going on there. So let's say this is the triangle we formed, where this is the point O, and let's say this is where the block initially was, and this is where the block is right now after moving some distance y. Okay, and okay, this is a right angle triangle. Do not go on the figure. This is y. This length was L. This angle was theta, and this length here was L sec theta, right? L into sec theta. Okay. Now, what is y? We can again find out y because you can see that tan theta should be equals to perpendicular by hypotenuse, right? That is one way to find out y. We are going to get into that part later on. But we need this x because the force of the spring, so let's call it Fs, is basically equal to k into x, where x is the extension of the string. So in on the block A, when it has moved some distance, let's say this is the block A, and this is the ground here. Okay, this is the ground on which it is standing, like right here. Okay, this is the ground, and the block has moved some distance, like here. Okay, so first of all, it is the gravity acting on it is giving a force mg downwards, right? The ground basically gives back a reaction force, which is the normal force upwards, which is r. Okay, now along this block is also acting a tension on the right, as you can see from the pulley. The tension on the right is basically T, and also you can understand there is the spring which has been attached to it, which is also pulling it back because it has been extended. So it's now pulling it back with some force F. Now, what is this angle? So this angle here is same as this angle, right? And if this is theta and this is 90, this must be pi by 2 minus theta, right? Because in a triangle, the sum of the angles is 180-degree. So if this is 90 minus theta, the horizontal component simply becomes F into cosine of pi by 2 minus theta. And the horizontal and the vertical component is F into sine of pi by 2 minus theta. Okay. So all in all, the forces which are acting horizontally, so horizontal forces, and we are taking right hand side as a positive direction. So horizontally, the forces acting on it should be T, and here you have F sine theta because cos of pi by 2 minus theta is sine theta. So T minus F sine theta. Okay. And vertically, we have R plus F cos theta. We are taking the upwards direction as the positive direction minus mg. So these are the vertical and the horizontal forces acting at any point on the block before it falls off the edge. Okay, because as it falls off, there is no reaction force. Now understand this: since this angle theta varies and the block moves forward, that means in order for the block to remain on the plane, the vertical forces must balance each other. Now that is only possible because mg is constant, right? But f sine theta varies. And since f sine theta varies, in order to compensate for that change, r also varies. So essentially, r is also a function of theta. The reaction that you get from the ground from this box on this block A is also varying as theta is varying. Okay. Now, from this we can get a good idea of what's happening, and we can write down the equation of motion for block A. So the equation of motion. Now, the equation of motion for a block, since the block is moving towards the right, let us assume the acceleration of the system is basically a. Okay. Now, according to Newton's laws, F equals to ma. So, if F equals to ma, we can write the forces on the right must equal to mass into acceleration. So, what are the forces on the right? The forces on the right is simply T minus F sine theta equals to m into a. Okay, where a is the block of the acceleration of the whole system. Now, since we have done this, we are also going to understand that the vertical forces are equal. That means we can also conclude this r plus f cos theta is equals to mg. Okay, r plus f cos theta is equals to mg. This is also something we have. Okay, now let's talk about this one. Let's talk about block B. So what's happening in block B? So you can see in block B, the tension is acting upwards and mg is acting downwards, and the system is going down with a velocity with an acceleration a. So the equation of motion of block, so this is for block A, and now for block B, it is simple because it's going downwards. We can write mg minus T is equals to ma. Add these two equations. So let this be 1 and let this be 2. If you were to add these two equations, what would you get? You will simply get mg minus f into sine theta is equals to 2 ma. Okay. And once you get this, we can find out the values from here more certainly. But before that, we need to do something else as well. So first of all, this a acceleration here is also dependent on theta that you have to understand. And the f is basically k into x. Okay. So let's write this down. So mg minus f sine theta. So mg minus f is simply, as I said, f is the force on the spring. So let's call it fs actually. That's more suitable. So this is basically k into x sine theta equals to 2ma. Okay. Okay. Now we need to find out what is the value of a. Now, after we obtain this, we can now find out the value of acceleration from this. So acceleration should be basically 1 by 2m whole into mg minus kx sine theta. And if you were to put the m inside, it should simply give you a half whole into g minus k by m into x sine theta, where x is the extension of the string. Now this is your value, this is your a, and you can say this is your a theta because the acceleration also changes with the value of theta. Okay, so this is your a theta. Now let's understand how to find the velocity of the block because this is important. Again, let me draw a figure. Let's say the block was here initially, and the block moved here, right? And this is the distance is covered. So let's call this distance as y. Let's say this length is L, and let's say this is the angle theta, and this is the point O. Now, if you find out sine theta here, and okay, this is the extension x, okay, the extension x, which is equals to L of L sec theta minus L, right? Anyway, sine theta should be equal to this y upon this hypotenuse, which is x plus L, right? So basically, this extension is okay. This is not x plus L, so we can simply write it L sec theta. Actually, that actually saves a lot of trouble. Let this be L sec theta. Anyway, so y basically becomes L sec theta into tan theta, okay, which is nothing but L tan theta. Now, why am I trying to find the value of y? Because since y is the distance or the displacement of the block, right? So if we can find dy by dt now, which should be the velocity of the block A with respect to theta, because the velocity also changes as the angle changes, right? So dy by dt would give you the rate of change of the displacement with respect to time, which is essentially the velocity. Now, if you differentiate L tan theta, you simply get L into sec squared theta into d theta by dt. This is important because theta is a function of t as well. And from this you can derive dt is equals to L sec squared theta d theta by v theta. Okay, I'm just gonna call it v theta, which is the velocity of block A. Okay, so this is what we got. Now the acceleration was this, and we also know that velocity at any point theta before it falls off is equals to 0 to theta acceleration of theta d theta. This is because the initial velocity is 0, and this is by the definition of velocity and acceleration, right? This is how they're related. Now, let us put back the value of a theta here. So v theta should be equals to 0 to theta. The value of a theta was, I think, half whole into g minus k by m, and let's see, kx by m, right? Kx by m sine theta. Okay, k by m into x sine theta. So this was basically essentially the value, and there would be dt. Sorry, this should be dt, right? Because a theta dt is what we are trying to do now. So what is the value of dt? The value of dt is L sec square theta d theta by v theta. So we will do that first by doing v theta equals to 0 to theta, writing this expression first. So g minus k by m, and now x is basically L whole into sec theta minus 1 into sine theta. So this completes the inner expression, and now dt is equals to L sec square theta, L sec square theta by v theta into d theta. So it completely becomes an integral of like theta. Now, using Leibniz rule of differentiation, we can differentiate both sides to get this v prime of theta. So differentiating left hand side gives you v dash theta, and right hand side simply gives you this expression using the rule of differentiation under the integral sign. So you simply get half g minus kl by m, and if you put in sec theta sine theta inside, you simply get, I think, tan theta minus sine theta. Okay, and with this you are also multiplying L sec squared theta by v of theta. Take the v theta to the left hand side, so this becomes v prime theta into v theta, and take this 2 as well, like this. And now we have, let's multiply this out. So the first term basically is gl sec squared theta. The next term is k l square by m tan theta sec squared theta, and the last term should be k l square by m. So you're multiplying sine theta and sec squared theta. So one is tan theta, one is sec theta. So basically sec theta into tan theta. So this is your expression. Now using chain rule, you can understand that this expression on the left hand side is nothing but d d theta of v theta whole squared. If you were to differentiate this, you would simply get this. which is equal to this expression right here, which is nothing but GL sec square theta minus KL square by M tan theta sec square theta plus KL square by M sec theta tan theta. Now, integrate both sides from 0 to theta, and the left hand side would simply become V theta whole square, and the right hand side would look something like this: 0 to theta, GL sec square theta d theta minus KL square by M. Let's take this common, and inside we write 0 to theta tan theta into sec square theta d theta minus 0 to theta sec theta tan theta. So d theta. This is your expression. We can do this integral very easily because all of these are almost standard integrals. So GL sec square theta, the integral of sec square theta is tan theta. So this will basically gives you GL tan theta minus KL square by M common. And then you have this tan theta into sec square theta. If you substitute for tan theta, this basically becomes your derivative of tan theta. So this is basically tan square theta by 2. You can try and do this integration on your own. Minus, this is sec theta tan theta. This is sec theta's derivative. So you simply have sec theta minus sec 0, which is basically minus sec theta plus 1 is what you have. So this completes your integration, and therefore the general value of theta at any general value of v at any point according to the theta, which is the angle that the spring makes, is given by root over of GL tan theta minus KL square by M whole into tan square theta by 2 minus sec theta plus 1. This is the general value. Now coming back to the problem, we remember the reaction force R was F minus mg cos theta or something like this. And this reaction force has to be 0 as the block falls off. So this would basically mean that F is equals to mg cos theta. In the beginning of the problem, I had told you that K was equals to 5 mg by L, and put in all the values. You should simply get cos theta equals to 4 by 5, which means sin theta is equals to 3 by 5. If we plug in those values and we find out the velocity, it basically is the v should be equals to root over GL. Now tan theta would be 3 by 4. So 3 by 4 minus K was 5 mg by L into L square by M minus, now tan square theta is 3 by 4 whole square, which is 9 by 16. So this is 9 by 32 minus sec theta is nothing but 5 by 4 plus 1. This is your expression. Now let's simplify this. This basically gives you 3GL by 4. This M and M cut off, and there is a L which is getting cut off. So this is minus 5GL, right? And into the 5GL we have tan square theta by 2. So okay, I do not know why I wrote this. This is not required. 9 by 32 minus 5 by 4 plus 1. So take 32 as the LCM and you get 9 minus this is 8. So which is 40 plus 32. So 32 plus 9 is 41 minus 40 is 1 by 32. So simply you get 3GL by 4 minus 5. So 5GL by 32. And the answer should be, if you take 32 as an LCM again, should be 24GL minus 5GL. So 24GL minus 5GL, which is nothing but 19, which is 19GL by 32, which is the required value of the velocity. And thus we have completed the question. So this was a pretty hard one, I would say, but doing this kind of questions really freshens up your basics and fundamentals. So let me know in the comment section how you like this. And we used a lot of concepts from differential equations, integrations, calculus, and also Newton's laws of motions and some basic mechanical theories using F equals to ma and how pulleys work and stuff like that. So anyway, thank you for watching. Let me know. I will try and bring more of this content.